Welcome to Tech Talks. I am your host, SSB. And in today's episode, we're going to explore the exciting world of computers and uncover the differences between the computers we use every day and the ones that are set to change the world. So, grab a snack, sit back, and get ready to be amazed as we dive into the world of traditional and quantum computing. These are the laptops, desktops, and smartphones that we use every day. They use something called binary code to store and process information. Binary code is made up of zeros and ones, which are called bits. Think of it like a light switch that's either on or off. To give you an example of how this works, let's say we want to calculate 2 plus 2. The computer would first convert the numbers 2 and 2 into binary code 0010 and 0010. It would then use a set of rules called logic gates to add the numbers together 0100 and give us the answer 4. Now, imagine you're trying to find a needle in a haystack. Traditional computers can search through a large amount of data, but it takes time and resources. It's like trying to find a needle in a haystack by hand. It can be done, but it takes a lot of time and effort. And there comes the solution. Now, let's talk about quantum computers. These are a newer type of computer that use something called quantum bits or qubits for short. Unlike traditional bits, qubits can exist in multiple states at once. This is called superposition. To give you an example of superposition, let's say we have a coin. In the classical world, a coin is either heads or tails. But in the quantum world, a coin can be both heads and tails at the same time. This is similar to how qubits can exist in multiple states at once. Another key concept in quantum computing is entanglement. This means that two qubits can become linked in such a way that the state of one qubit is dependent on the state of the other. Now, imagine you're trying to find a needle in a haystack. A quantum computer can search through a large amount of data at once. It's like having multiple hands searching for the needle at the same time. This makes quantum computers highly powerful and capable of solving problems that traditional computers can't even tackle. So, what does all of this mean for the future of computing? One of the most popular problems in computer science is the needle in a haystack problem. This is where you have a large number of items, and you need to find a specific item in the list. For example, let's say you have a list of 1 billion phone numbers, and you need to find a specific number. This can be a very time-consuming process, even for the fastest computers. Quantum computing offers a solution to this problem by using quantum algorithms such as Grover's algorithm. Grover's algorithm is a quantum search algorithm that can find the target item in an unsorted list of n items in only square root n steps. Let me explain how it works. Imagine you have a group of people standing in a room, and you need to find a specific person wearing a red hat. In classical computing, you would need to search each person one by one until you find the person wearing a red hat. This would take a lot of time, especially if there are many people in the room. In quantum computing, Grover's algorithm uses a quantum mechanical trick called quantum parallelism to search all the people in the room at the same time. This allows the algorithm to search much faster than classical computers. Now, let's apply this algorithm to the needle in a haystack problem. Suppose we have a list of 1 billion phone numbers, and we want to find a specific phone number. Grover's algorithm would search the list in only square root 1 billion steps, which is approximately 31,623 steps. This is much faster than the classical approach of searching each number one by one. Quantum computing is still in its early stages, but it has the potential to revolutionize the field of computing. It has the ability to solve problems that are impossible to solve with classical computers, such as simulating complex molecules and cracking encryption codes. One example of this is in the field of cryptography. Traditional computers can be used to crack encryption codes, but it takes a lot of time and resources. Quantum computers, with their ability to exist in multiple states at once, could potentially crack encryption codes much faster, making our online transactions and communications much more secure. Another example is in the field of artificial intelligence. Quantum computers can help with machine learning and neural networks to improve the accuracy and speed of the AI models. In the field of logistics, quantum computers can help with optimization problems such as scheduling and routing of vehicles, and this would lead to more efficient and cost-effective logistics systems.
Don't know why I'm losing my mind. Ego was so strong inside.
In conclusion, quantum computers are the future of computing. With their ability to exist in multiple states at once, they have the power to solve problems that traditional computers can't even begin to tackle. From cryptography to medicine, quantum computing has the potential to revolutionize the way we live our lives. Once we get our hands on a quantum computer, then what's the first thing we must try? We can try playing Cyberpunk with RTX on. Comment down your thoughts. What would you do if you have your own quantum computer? And thanks for watching. Hope you enjoyed learning about the differences between traditional computers and quantum computers. Hit like if you liked it or hit dislike it if you disliked it, but don't forget to hit the subscribe button to stay updated with our latest tech talks. And as always, if you have any questions or comments, feel free to reach out to us. See you next time on Tech Talks. Have a nice day.